Hi, welcome back to the corporate finance class. In this chapter, we're learning a new concept, time value of money. We talked about it before. The money has different values and at different times. So this one is a very basic concept, but it's very important. It's a foundation for all the future chapters. And we're learning future value and present value, two very important concepts in this chapter. About future value, we're learning how money compounds. The value will increase as time passes by. And how do we discount the future value back to the present value, back to the current time's value? And some other concepts about present and future values. Let me drink some water. So the present value is the earlier money on a timeline. What is a timeline? Think about time from now at time 0 and it goes into the future. Like this. This is timeline. So you see, why do I use 3 stars? Because I like stars. So the first star is year 0. Year 0 means that zero time has passed by from now. And year 1 means that 1 year has passed by from now. So there is an interval, a gap, about 1 year between year 0 and year 1. The value of some money at year 0 or the current time is called the present value. And this line from now to the future, to the end of the year 1, the first year, and then to the end of next year, the end of year 2, the end to the future, this line is called a timeline. We will use this timeline model to illustrate a lot of concepts that we're going to learn in this chapter and future chapters. A future value is a later money on a timeline. The exchange rate between earlier money and later money is called interest rate. We also talked about this in the very first lecture. Remember, the interest rate has a lot of other names. Discount rate, which means that, well, interest rate is called interest rate because if you have money today, and you deposit this money into the bank, and this bank will generate interest. Okay, the interest gain to you. So that when you save the money, deposit the money for 1 year, at the end of the first year, you will have more money than today's money. For example, if you're depositing $1 million today, and the interest rate is 2%, then you will have $1.02 million at the end of the first year. Because when you deposit the money generates interest to you. So this exchange rate is called the interest rate. You can also call it a discount rate. When you're saying, well, at the end of the first year, in 1 year, you will have $1.02 million. What is the value of money if you discount it to today? So from today to the future, this rate is called interest rate. And from the future to today, we call that, we discount the money's value back to today. Okay. Why is it also called cost of capital? Because when you are depositing money and you receive interest gains, the interest gains are paid by the borrower, by the person who borrows your $1 million. And to that person, this money has a cost. The cost is interest gains that you are paying, that he is paying for you. So it is that person's cost of capital, the capital of $1 million that he is obtaining. You can also call it opportunity cost of capital because if you are investing your money into one project, you are forgiving, you're giving up another project, potential project that you could invest in. Well, at the equilibrium of the economy, all the projects' exchange rates of the money, the interest rate, should be the same, plus their interest premium. So the opportunity cost of capital is also another name of interest rate, but it's not very often used. Required return is also based on this concept, since many projects on the market, they're competing for potential investors. Project A's interest rate could be 2%. Then for project B, what return do you require as when you're an investor? You require also the same interest rate. So required return is also an alias of interest rate. On most occasions, there's the same thing. You just need to remember that whenever you see these concepts, just remember that they are interest rate. When we have $1 million today, it is called present value. When we save it, and we know that in 1 year is $1.02 million is future value. What about we save it for another year? What is the value of this money at the end of the second year, in 2 years? The answer is, it is also the future value. Present value and future value are two related concepts. For example, if you save the money here at year 1, and then year 2's money value is the future value of this year 1 money's value. And year 1 money's value is the present value of the year 2 money's future value. We say you discount the year 2 money's value back to year 1. So compared to year 2, year 1 can be year 2's present. Since we're standing at year 0, so year 1's value and year 2's value both are future values. Okay, so they are relative concepts. Suppose you invest $1,000 for 1 year at 5% per year. What is the future value in 1 year? You first calculate the interest again, which is $1,000 times the interest rate. And you find 50 is the interest gain that you're getting. The value of this money in 1 year is the $1,000, we call it principal, plus interest. So the value of money in 1 year is $1,050. The future value is this $1,050. And you can see this 50 as 1,000 times 5%. So future value is 1,000, the principal, the present value times 1 plus the interest rate. Okay. Suppose you leave the money for another year. How much will you have in 2 years? And this is the value of money, 1,000 times 1.05. This is the value of money in 1 year. And you save this whole bunch of money for another year, so you get another 5% interest. So together you get 1,000 times 1.0 squared to the power of 2 equals $1,102.5. The general formula for futures, the future values, is future value equals present value times 1 plus r to the power of t. Future value is FV, present value is PV, R is the period interest rate. Remember that this is a period interest rate. We say this is yearly interest rate just because in this example, we compound yearly. That means we pay the interest gains every year. What if we pay the interest every month? Then the period will be monthly. You will have to use a monthly interest rate, which is 5% divided by 12. And the number of periods will not be just 1 year, will be 12 months. And also remember, it's pretty tricky here, the T is not the year number I'm indicating here. It's a number of intervals. It's a number of periods on this timeline. If you have money at year 1 and you save it for 4 years and you can get the money at the end of year 5, what is T? It's not year 5's 5. It is 4 intervals, 4 years. Because between year 1 and year 5, you have 4 years. Number 1 year, 2 years, 3 years, 4 years. And T will be that 4 years if the interest rate is, the interest is compounded yearly. Okay. We also call the future value interest factor 1 plus r to the power of t, because this is the total interest rate between exchange rate between future value and the present value. There is a difference between simple interest versus compound interest. Consider the previous example. If you have the simple interest, means that when you deposit the money into the bank for several periods, for example, several years, each year you only get the interest from the principal, but not the interest from the interest that you previously gained. So the future value with simple interest from the previous example will be 1,000 plus 50 plus 50 will be 1,100. But here you see that we calculate the compound interest rate, 1 plus 5% squared. And in total we got an extra $2.5. Where is the extra $2.5? This $2.5 comes from the interest of 50, the first year's interest gains. Okay. So when you're earning interest from the previously paid interest, that is called compounding or compound interest. How do we calculate the present value? So this is a question about how much do I have to invest today to have this some amount of money in the future? Okay. That is, if I want to have $1.02 million in 1 year and the yearly interest rate is 2%, how much money do I need to have today? If I want to have $2 million from a project and the market interest rate is 5%, how much money do I need to invest today? We rearrange that formula, we get PV equals FV divided by 1 plus R to the power of T. And this is what we call discounting. We discount the future value back to today to get the present value, and we compound the present value to the future to get the future value. Okay, when we are talking about discounting, we mean finding the present value of some future amount. So now you know that the value can mean different things at different times. When we talk about the value of something, we're talking about the present value, usually, unless we specifically indicate that we want the future value. Okay. For a given interest rate, the longer time period is, the lower the present value, if the future value is the same, which is obvious from this formula. When R is going up, FV holds constant, and the PV is going down. Okay. Well, no, that is for this one. For this one, for the first one, is the longer the time period is. When T goes up, this one goes up, then PV is going down. And for the second relationship, the higher the interest rate is, the smaller the present value. When R is going up, then PV is going down. Okay. This is the financial calculator that you're going to learn from the tutorial, from the TA. Okay. And in the financial calculator, the rate is the R, the interest rate, and the N is T. Okay, and this is FV. So, according to this formula is the core of this chapter. There are 4 parts to this equation: PV, FV, R, and T. If we know any 3 of them, we can solve for the 4th one. Let's calculate the R, the interest rate or discount rate. We can rearrange this basic the PV equation, and so for R, we use FV divided by PV equals 1 plus R to the power of T. Then we take to the power of 1 over T on both sides. Then we can have 1 plus T equals this guy. Okay, FV divided by PV to the power of 1 over T. Now R is equal to this one. So if you're looking at the investment, that will give you $1,200 in 5 years. If you invest $1,000, the PV is 1,000, FV is 1,200, T is 5 years. Okay, if the interest rate is calculated yearly, we use this. We calculate the yearly interest rate using this formula. And on the tutorial, the tutor, the TA will teach you how to use this financial calculator. How do you calculate the number of periods? T. You rearrange this formula, you can get T is equal to the log of FV divided by PV over the log of 1 plus R. Okay. So this is a summary of the formulas. If you have when you have the 4, you can have the future value of the investment and the present value of the investment. And the following slides are tutorials. Will be taught as tutorials by the TA. This is a calculator keys. You're advised to buy the Texas Instruments, the TI-BA2 Plus, or some similar models. And I will skip this and leave it to the TA. Okay, let me just go over this one by one slowly. Okay, this is the end of the slide.